Hello students, so today we're going to talk about how to set up proportions and how to solve proportions. But before we do that, I want to talk about how algebra, which we're doing in math class, can be found in geometry. So for instance, here are two iWoBATs. I will be able to write geometric proportions and solve geometric proportions. Please write those down for today's objectives. Hit pause if you need some more time. All right, we have our first definitions, similar figures. We talked about this yesterday. Similar figures need two things to be similar. One, corresponding angles are matching, are the same, and corresponding lengths are proportional, meaning that they have a scale factor. So looking at these two triangles, you can tell if I go from triangle A to triangle B, like if I have 5 and 15, since those are corresponding side lengths, 5 times what is 15? 5 times 3. If I go the other way, 15 times what is 5? I just do the opposite or the reciprocal of 3, which would be 1/3. You can also kind of set up your corresponding side lengths and see if they can be reduced to the same thing. For instance, if you look at 3/9, so 3 and 9, 3 over 9. 3 over 9 can be reduced. Divide by 3, divide by 3, that would be 1/3. 4 12s, their corresponding side lengths. 4 over 12 can be reduced. Divide by 4, divide by 4, 1/3. And again, 5 and 15 are corresponding side lengths. 5 over 15, divide by 5, divide by 5, 1/3. If you notice, they're all proportional to each other. They all can be reduced and get 1/3, meaning they're equivalent, they're the same, and that's how we get our scale factor. So what this means is that when you don't know a side length of a similar figure, you can use your knowledge of proportions to find the missing side length. So I'm going to tell you right now how to do that. Anybody Celtic fans? All right, so let's do an example. So we're going to match up, we're going to make a ratio out of our corresponding side lengths, okay? So I'm going to start over here. So I have my base. So 12 is my first side length I'm going to deal with, and then corresponding to that is 8. So I'll go 12 over 8. Now if I look over here, put a little equal sign in the middle. Since I started with this, we'll call this A. Since I started with A, I'm going to leave A up on the top, and we'll call this B. So 6 is going to be across from my 12, because they're on the same. And X is corresponding to that, but I don't know what X is, so I'm going to leave it on the bottom. So you can kind of see, how could you find this missing side length? Well, something you could do is solve it a proportion. You're going to cross multiply. So you're going to do 8 times 6. And then the other side, 12 times x. We don't know what x is, so we're just going to leave it 12x. 8 times 6 is 48. Now we have to get that x by itself. And remember, between the 12 and the x is multiplication, and we want to get rid of it, so we want to do the opposite operation, which is division. So I'm going to divide both sides by 12. This is going to cancel, leaving me with x. 48 divided by 12, that's going to be 4. And you can use a calculator if you need to. So x equals 4. You could have also said, okay, 12, I have 12 and 6. What's the relationship between that? Well, half of 12 is 6. And so then half of 8 would be 4. So that's another way you could do it. Then it's basically just go with what I just did. We cross multiplied. And then we solved and got x equals 4. Let's go ahead and do example 2. So there's another way you could set up example 2. I like to make myself a little legend on the side. So maybe you want to set up your triangle by saying height over base. Okay, that's how I'm going to set up my proportions, my ratios. So first one, height over base. Well, my height I don't know, so I'm going to leave that x. My base is 6. Over here, I'm going to do the height over base. So that's how I set that up. And if you notice, across from each other, x and 10, those are corresponding side lengths. And across 6 and 3, those are corresponding side lengths. So I have x over 6 equals 10 over 3, and I'm going to cross multiply. X times 3, that's going to leave me with 3x. In the other side, I have 6 times 10, which is 60. I'm going to then divide both sides by 3, and x will give me 20. Like so. You could also use a real-life example. For instance, we have a father and son here. The father is 6 feet tall, and we have a son that we don't know how tall it is. If you look, the father-son kind of make a triangle. I guess they share the same angle. They don't really tell you the problem, do they? So this would be 3 feet, and this would be 2 feet from this point that they both stood at. If we set up our proportion, you'll have the height of the dad over the height of the son. The height of the dad over the base of the triangle. And then we don't know the height of the son, but we know the base of his triangle was 2. So then we'll cross multiply and solve. 6 times 2 is 12, and 3 times x is 3x. If you divide both sides by 3, x equals 4. So the son is 4 feet tall. So now I'm going to give you some examples. I want you to go ahead and solve them. You can use them on a whiteboard if you want. You don't have to. You can use paper if you do not want to get up to get a whiteboard. And I want you to go through these examples. Go ahead and try the example, and I will give you the answer. Please pause this so that I can show you the answer after you do the work. There's the example answer there. 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 Please email me if you have any questions. Good luck on the homework. Please finish it for Monday.